And for the no-mass questions, in how many ways can a convex n-gon be divided into triangles by non-intersecting diagonals? So, for example, if we have a rectangle, then there are two ways here and here. And then what is the number for an n-sided polygon? So first consider we fix the side of the polygon and trying to draw a triangle attached to this side. So for this case, we can draw it here, 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 here. And consider this case. We have drawn a triangle here. So the number of possible ways is the number of possible ways to divide this part into triangles and times the number of ways to divide this into triangles. And for this part, it's equal to the number of ways to divide this line into triangle, which is we let this be 1, and the number of possible ways to divide this into triangles. So we can get this recurrence relation, where Cn is equal to C2 times Cn minus 1 plus C3 times Cn minus 2 all the way up to Cn minus 1 times C2, which can be written in this form, which J is equal to 0 to n minus n plus 1, and Cj times Cn minus n plus 1 minus j. And to simplify this equation, I let Cn equal to dn minus 2 for some dn. So we can get dn minus 2 is equal to d0 times dn minus 3 plus d1 times dn minus 4 all the way up to dn minus 3 times d0, which we can write here as j start from 0 to n minus 3. And dj times dn minus 3 minus j. And d0 is equal to 1, C2. As you can see, this recurrence relation is actually the recurrence relation of the Cartesian numbers again. So we can get the n minus 2 is, and the starting condition is also the same. So we can get actually dn is the Cartesian number. So the number of ways to divide an n-sided polygon into triangles is actually equal to the n minus 2's Cartesian number. So is everyone okay with this question? Okay, so this is all of our homework. Is still any question regarding to this homework or other things? No? Okay, so we should resume our class. Oh.
So let me, so there are some minor points I want to draw. Number one B. So if you look at this, yes. So if you look at this, what is it? So we have a complex number. Whenever we have a complex number here, think about it as what? As some cosine theta plus I sine theta, right? So if you look at this, so this will be like 1 over 2 plus square root 3 over 2i, right? So what angle is that? So it's like there is an angle such that cosine theta is 1 over 2 and sine theta is equal to square root 3 over 2. So what is that theta? is pi over 3. Yes, pi over 3. So 60 degrees, right? So what does that mean? So this is 60 degrees, and then this one is minus 60 degrees, right? So what does that mean? So it means that after 6 steps, so it will go back to itself. So if, right? And this one also, after 6 steps, so if r becomes r plus 6, then this part will be the same as before. So this number to the power r is the same as this number to the power r plus 6. And similarly, this number to the power r is equal to this number to the power r plus 6. And what does that mean? So it means that ar is equal to ar plus 6. So there is going to be a cycle of length 6. So let's try. This one is easy. Maybe we can try. So we have what? We have a0 is equal to 2. So a0 is equal to 2. And then a1 is 1. And then a2 is also 1. Right? So how about a3? So we know that a3 is equal to 2 times a2 minus 2 times a1 plus a0. Am I correct? So a3 turns out to be equal to 2. Is that okay? Is that okay? And how about a4? So let's take a look of a4. a4 is equal to 2 times this one minus 2 times this one plus this one. Okay, so 2 times this one is 4, minus 2 times this one becomes 2, and then you add 1, so it should be something like 3. Am I correct? Is it right? So how about a5? So let's take a look. a5 is equal to 2 times this one minus 2 times this one plus this one. So it is going to be 3. Am I correct? Eh? Okay, so this is going to be 3. And how about a6? a6 is 2 times this one minus 2 times this one plus this one. So it is equal to 2. Let's continue to do a few more terms to confirm our finding. So what is a7? a7 is 2 times this one minus 2 times this one plus this one. So it is 1. Is that okay? And then a8, let's do a8. a8 is 2 times this one minus 2 times this one plus this one. 1. Okay, so you get 2, 1, 1, right? So you start with 2, 1, 1, and then you get 2, 1, 1. So after that, it must be 2, 3, 3. And then 2, 1, 1, 2, 3, 3. So you get a cycle of length 6. So you go from a0 up to a5. This is what we have. And this is, so if you look at something like this, and then let's say the angle is beautiful, then try to confirm your answer. So of course you can write down the answer like that. Okay, yeah, and without even need to. So if you look at this, okay, and then you figure out that, oh, the angles are so beautiful, then don't try to bother to find out what is ABC. ABC is much difficult. You list them out. After you list them out, then all these are simple numbers, right? And then you don't need to find ABC there. That's difficult. And then that is also a perfect answer, right? And then you just write down a0 up to a5 is equal to this one, and then you say that ar plus 6 is always equal to ar. Or you may even write down ar. So because it has a length cycle, so ar is equal to ar, you take the modulo of 6. Is that okay? That will be the same. Okay. So this is one thing. Yeah. And then the other one is, let's try this one. Yeah, so Simon's proof is very nice. Okay. So but this one, so for me, I'm going to use the intersection idea from the lecture, and then to solve this. So it will be much longer. It will be not as neat as this one, but still we can solve it. So we will be using the same basic idea. So let's say we now know how many regions are there. How many triangles are there in the case of r minus 1. So let's say this is the case where we have r minus 1 vertices. So what happens if I add one more vertex? So how many triangles will... is it asking triangles or asking regions? Regions. So how many regions will I get? Okay. So the same as what Simon is doing. So we are going to... So at the beginning, we are going to add 1, because just have this one. So I will be writing down 1. Okay. Now, what is going to be added next is, like, because we are by adding this one, we are going to have a lot of diagonals, like what Simon is drawing. So I have a diagonal like this. So by drawing a diagonal like this, what is the number of regions that I'm going to create? So I'll be creating 1, because I'm joining this to this edge, right? 1. And then for each new intersection that we have, then there will be another one. Is that okay? So it is going to be, for each diagonal, 1 plus the number of intersection. Is that okay? So for this diagonal, it will create, let's say there are k1 intersections. So it will create 1 plus k1 number of new regions. So if I have another diagonal, maybe like this is another diagonal. Let's say this is another diagonal, and then let's say this time there are k2 intersections that is made by this diagonal with the existing diagonals, then it will be creating 1 plus k2 new regions. Does that make sense? Okay. Okay. So in that case, we will know that. So how many diagonals I'm going to draw? So how many diagonals? Maybe. So how many diagonals I'm going to draw? So altogether there are points, right? Without these 3, there are minus 3 points, right? So I'm going to join this one to all. Yeah, actually there is a diagonal like this, and there is a diagonal like this. Am I correct? So I'm going to draw r minus 3 diagonals. Is that okay? So the number of regions that I have not counted will be r minus 3 plus the number of intersections that we are going to have. Is that okay? So the number of new intersections that these diagonals is going to make with the existing one. And then how many intersections are there? How many intersections? So for, let's say, so we have, let's say again, let's use this as an example. So this one, r minus 1, let's say this is equal to 6 in our example. Is that okay? And then this is a new point, and let's say we are drawing this diagonal. So how many intersections are there? There are going to be 3 points here. Am I correct? Eh? Let me see. How many diagonals are there? Well, this one is not a diagonal, right? But let's complete this. So this will be actually equal to what? So think of this as an existing diagonal together with this edge. So this will be the diagonals in the new polygon, I would say. So how many diagonals I'm going to so it will make an intersection with this one, with this one, with this one. Am I correct? And then it will make an intersection with this one, this one, and this one. Am I correct? And then it will make an intersection. No, that's it. Is that okay? So how many intersections are going to make? It is going to be the number of points here. So 1, 2 times the number of points here, 3. 2 times 3. Is that okay? So the total number of intersections you can find. So this is going to be, if you count it, so it is going to be, in the extreme case, if I'm looking at this diagonal, it will be 1 times the number of vertices on this side. Is that okay? So this is how many vertices? This is going to be how many? So if this is 1 here, how many are there? R minus 2, R minus 3, am I correct? Is it? Or is it? Let's count, okay. Altogether R. Altogether R. I don't count this, I don't count this, I don't count this. So that should be R minus 3, am I correct? So we will have 1 times R minus 3. And then, if I'm looking at a different diagonal, so this one, this is a new diagonal, this diagonal, then I will be having 2 here times R minus 4, am I correct? So add 2 times R minus 4 plus 3 times R minus 5 plus dot 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 up to R minus 3 times 2. Is that okay? Is that okay? So after doing this, so it remains to show that this part is exactly equal to the term that we want. So it is going to be R minus 1 choose 3. So if we can do that, then that's nice. Is that okay? Is there a quick way to show that this is equal to what? Well, I'll leave it for you. This is not that difficult. It looks like what? So, is it easy? Let me see. Let me see. Oh, thank you. Thank you. Yes, this should be one. Yes. Thank you. Well, okay. So how about we end the class today, and then if you are interested, yeah, let's think about this together. Okay, so if you want to leave, yeah, please just leave now. I think there should be an easy observation that this is equal to R minus 1 choose 3. Yeah. Okay. Double check. So R minus 1 choose 3, right? So if R is equal to 4, no. R minus 1 choose 3. R minus 1 choose 3, so 4 minus 1, so it's equal to 1. So it is 4, yeah, that's right. Yeah, so this is a convolution of what? So 1 plus x R minus. Yes. Is equal to okay, good. Yeah, so we should be finding the x to the power what? R minus 3 in this one. So this is the answer would be equal to. So it is equal to minus 4 choose R minus 3 times minus 1 to the power R minus 3. So this is going to be R minus 1 choose. Is it? minus 3吗？是 r minus 对不起 r minus no r 吗？ So it is going to be r minus 3. Yeah. R minus 3 plus, if we start 1, 4 minus 1 plus 4. Let me see. Minus 1 minus. Okay, so what is the last term here? So it's going to be somehow something wrong. Oh, choose r minus 3. 对呀。something wrong. 讲中文，有点错哎，为什么？r 去4在哪里错？是 r 取3吗？还是 r 减1取3？你刚才是 r 减1取3吗
，r 减1取，
对吗？但是我现在弄到 r 取3嘞，为什么？再想清楚。
是 r 加1边形是
r 边形，是。我那个是1的1要乘 r 减3嘛，对吗？对啊。然后这边没弄错嘛，对不对？这边应该要找 a 的 r 减3 ，a r 减3这个 term 嘛，对吧？因为 a r 减3就是那个 x power， 就是 x 的 power r 减3嘛，对不对？你就要弄一个1乘以对，这边错了，这个2的不是平方，对，错了，这个我要找的不是这个 term， 我要找是哪一个 term？ 我要找的是 r 减4这个 term 才对。哦，对，我要找 r 减4嘛，我要找 r 减4嘛。对，我要找最后，对，我要找 a r 减4这个 term 才行，因为 a r 减4的那个 term 就是 r 减3乘以 a 的 x 的 r 减4啊，对，我要找 a r 减4，没错了，所以呢，这个是这样，这是 r 减4，这是 r 减4，这是 r 减4，这是 r 减4，对，等于 r 减1取3，对，没错。